Hi, in this video I'll be performing some technical tests on this RCT MegaPower T1000S sine wave inverter. Right, so over here is the display. Right, on the top of the unit I have a multimeter which does happen to show a graph on it. Then I have two loads there. There's a floodlight which is currently on, and then I have a grill here which is rated at 920 watts, which is about the maximum for this RCT inverter. Alright, so at the moment the inverter is on, and I'm going to start by switching it off over here. So it switches off the loads. You can see the light load is off, and on the display it even says the output is 0 volts. Now on the back of the unit I plug it in here on the AC input, but the battery will only work if it is in the on position. So this circuit breaker must be on. If it is off, and if I have that unplugged, the unit is completely offline now. Right, so in order to get started, I'm going to plug in my AC mains, and for now I'm actually going to leave this off, and I'm going to show you the operation with the battery disengaged. Right, so there's a red LED over here telling me the battery is offline. So even if I try and start it up, you can see that nothing is happening. There is no output. I have to lift up the circuit breaker at the back. So note, I've plugged in the mains. I try and press it on here. Nothing will happen until I lift the battery circuit breaker. When I lift the battery circuit breaker, it automatically powers on. I don't have to switch anything on. As you can see, the input voltage here is from the console. There's the 233 volts, but notice that the output immediately turns on. So the load is connected to the mains, whether or not I've switched on this power button over here. Now just having a look at this, we can see that the input is rated at 233 volts. So that is the console supply. Now this circle with a sine wave inside represents the utility, your console supply or ESCOM. Feeds into an AC to DC converter because it needs to charge that large lead acid battery that is inside the unit, which is what makes it so heavy. So there we can see it is currently in the charging mode. It is fed with 233 volts from the utility. The frequency is 50 Hertz. But notice here, the dotted line goes from there all the way over to the load. The load is currently very low because I only have a LED floodlight of 50 watts connected. I haven't connected that grill yet. But it says here, output is 220 volts. Now I'm going to measure that output and show you where this gets a little bit misleading. Right over here, I have a 3-pin plug. It is connected to my multimeter. I'm plugging it into the back of the unit, and there we can see my multimeter says 233 volts. The thing is, this is connected at the output. So here on the display, it says the output is 220 volts, but my multimeter says 233. Notice that the input there is 233. So what is happening here is the meter is measuring the output of 233 volts, but the inverter is actually saying the output is 220 volts. However, if I unplug the mains, so I've unplugged the mains to the inverter, notice now, and only now, the meter is now saying 223 volts. Yes, it is a sine wave. You can see the sine wave there. So now it's showing that from the battery, it is now converting DC to AC to my load. The bar graph here on the side is very low, so it is showing me it's a very light load. The input is at 0 because I've unplugged the mains. The frequency is at 50, which it is. It's 49.8, which is close enough. And the voltage on the output says it's 220. My meter is saying 222, but also close enough. But notice that now, only when the mains is unplugged do I get that 220 volts. And notice that the dotted line goes like that. When I return the mains is now plugged back in. Notice that it is now back in the charging mode, and the mains is now supplying the output. So even though it says the output is 220, it's not. The output is what the input is, which is 233. This is a little bit misleading. Right, so now it is charging the battery. Now, say for example, someone bumped the circuit breaker at the back and they switched off the battery. So the circuit breaker is now switched off at the back. Right, so the breaker is down. The mains is still plugged in. The load, there you can see the floodlight is still on. it tells me there's something wrong with the battery. The light is on, it's red. A red light means that the voltage at the battery is less than 11.1 volts. Well, in this case, it's 0 because I've disconnected the battery. So that is correct. But surprisingly, the display is still saying it's charging the battery. So I'm going to measure the voltage at the battery. All right, so this is the side view. I've opened up the side panel. Here is the battery. It is a gel battery. It is a 100 amp hour battery, and here are the terminals, the negative and the positive, and I'm just going to put my leads on them and take a measurement. If it is charging the battery, the voltage should be above 13.5 volts. If it is not charging the battery will be at its normal resting volt, which would be at about 12.7. Right, there we go. So it's 12.86. That is the normal voltage for a lead acid battery. So that means it is not charging the battery. Over here is the double pole circuit breaker, which disconnects the battery. I'm going to lift the circuit breaker and then I'm going to take a measure of the charging voltage. Right, and there is the charging voltage of 13.85 volts. That does depend on how discharged your battery was. So in my case, my battery was close to fully charged, so that is why the voltage increased so quickly. So that means that it's only charging the battery when the circuit breaker at the back of the unit is in the up position, even though the front display says it's charging the battery, even when the circuit breaker is down. Just for your reference, on the front, if I press and hold the function button for 5 seconds, I can change the mode of the unit. There it went to number 2. There is no description in the manual to tell me what number 2 is, but nevertheless, there is only a description for options 1 and 3. So I'm just going to put it to number 3 now. And now that it's at number 3, I just want to show you the charging voltage. I'm now at the same meter that was measuring the voltage across the battery, and it might look like it's charging the battery, but what's happening is that voltage is now dropping. Note that it's dropping as I'm talking, 46, so it's 13.46, 13.45, and it'll just keep dropping because it is no longer charging that battery. So for normal use, please make sure that the function is in mode 1. So over here, I'm pressing and holding for 5 seconds to get back into mode 1. And good luck trying to make complete sense of the manual that is provided. I think that's pretty much a fail. Manufacturers or suppliers need to provide a manual which is understandable to the end user. And now I have put it back onto mode 1 and notice that the voltage is now increased and it is now recharging the battery as it should do. Okay, so now that we've cleared that up, let's have a look at how it does the changeover. The changeover means that when the power goes off, the console power goes off, what happens to the load. So I'm going to plug in the loads again. Right, so I have the load plugged in, which in this case is that floodlight. And what I'm going to do is I'm going to disconnect the mains. So I'm unplugging the mains. There, the mains is unplugged. And there you may notice the changeover was quite rough. You might have noticed that the floodlight flickered a bit and it hesitated. That is not a good sign. So I'm going to plug in the supply again. Right, so it's accepted the voltage as correct, and I heard the relay go tick, which meant it changed over, which means that it is now feeding that floodlight directly from the mains. Now I'm going to unplug the mains again. The ideal scenario is that the output remains stable during the changeover. So I'm going to unplug the mains one more time. In this case, it was more stable. It was a faster changeover, but nevertheless, there was still that flicker. So what I'm going to do now is I'm going to do a series of unplugging and then plugging in, unplugging and then plugging in, and I'm going to see how the unit does the changeover. Right, so unplugging. Right, so it was fairly quick. Notice the flicker was quick, plugging back in. Unplugging, that was a bit more significant. The LED floodlight almost went completely off. Again, there the changeover from battery to mains was quite rough. Alright, one should ideally use oscilloscope to map out the waveform, but I'm just using the light because it gives a visual impression quite well. Alright, so keeping in mind that this is a very light load, it's only 50 watts. What I'm going to do now is I'm going to bring back my heavy load. Right, so now I've connected the grill. This is almost 1 kilowatt. And then I've still got the LED floodlights, only 50 watts. And what I'm going to do is I'm going to do the changeover now. Currently it's on mains. And I'm going to unplug, so it's going to be operating directly from the battery. Right, so there was the changeover, fairly good. But notice that the unit is now beeping twice every second. That is telling me that the battery voltage is low. It also tells me that it could be an over temperature alarm. I don't think it's an over temperature alarm because the unit has only been feeding this for a very short time. Right, so I'm going to switch off the grill and notice the alarm has gone off. Right, there you can see the load is low, but if I switch on the grill, notice that that little graph there has gone almost to 100%, and now it has got that beeping every 2 seconds. Once I switched off the grill, notice that that beeping has gone away. Right, so now let's see how it works with dirty power input. I'm going to use a generator to feed the unit. Right, over here I have a 220 volt generator. It's going to be the supply to the inverter. I'm going to start up the generator. I'm then going to plug in the inverter, and then I can only put loads onto the inverter. That's what it says in the instructions. Right, so the first thing we notice is that the output is no longer a pure sine wave. Because it is bypassing the supply directly to the output, remember that my meter is measuring the output of the inverter. So that graph you're seeing there is actually what is going to be fed to my loads. You can see that that graph has changed from a sine wave to triangular type wave because the generator does not give a pure sine wave. So will the inverter offer you clean power? Well, no, not if it is in the bypass or the normal mode. So if it's running off the mains, no. If it is running off the battery, yes. Right, so there's a closer view of that waveform, and what I'm going to do is I'm going to load up the generator. And the reason why I'm going to load up the generator is because these type of generators, when they get loaded, their voltage and frequency tends to drift. So I'm now loading the generator, and watch what happens to that waveform and the frequency. Notice how that waveform went from an almost triangular wave to a nice sine wave, but then to a jagged sine wave. Now, because of the type of wave that is outputted by the generator, the frequency goes all over the place. It drifts between about 47 to about 53. But how does the RCT inverter behave under this situation? And this is what my concern is. It's behaving like a line interactive UPS. What it's doing is it's noting the voltage to be correct, allowing it to be fed from mains. Then what is happening is the voltage from the generator is drifting, or the frequency is going out of range, and then the inverter is going to the battery mode, meaning that it's going to feed the load from battery. Then, because the generator becomes in spec again, meaning that the voltage from the generator, the voltage and frequency becomes in range again, then the inverter is fed from the mains. So what it's doing is it's actually oscillating mains, battery, mains, battery, mains, battery. And that is not good for the load because it is switching over the load constantly. Remember earlier I showed the floodlight being changed over and how there was moments where it went dark or it flickered. That is not good for our loads. Now, this is not necessarily a problem only on this unit. This is a problem with most line interactive UPSs and inverters. So I'm not specifically criticizing this product. What I'm saying is that if you are going to be using the product with a generator, maybe consider first using an online UPS to clean the power before being fed into the RCT inverter, which is true for most line interactive UPSs. Now, there's a menu to select option 1 or 3 by pressing and holding the function button for 5 seconds. Notice that the number has changed. It is now 2. I'm going to press and hold it for another 5 seconds. In the manual, it does not give an option for what the 2 means. I'm going to press it until it says 3. Right, it says 2 and I'm keeping it pressed in 5 seconds. Right, now it says 3. So if I leave it on the 3 mode, it's called the battery priority mode. Notice that it immediately switched from the battery even though the supply has a stable input. Now this is useful for 2 reasons. The first one is you can use your external supply. The second one is if you've got an unstable input voltage, for example if it's a generator, you can force the unit to feed the load via the battery. Notice that the load is now being fed directly from the battery even though there is an input, a stable input. Even if I switch it off, I've switched the load off, it does say it's charging the battery. And now when I switch the load back on, notice that it's now fed from the battery rather than from the supply or the mains, even though there is a mains voltage here. So in the case of a supply which is unstable, or like the one I showed with the generator, you can force the inverter to be running off battery, but then it kind of defeats the point because you're using the generator to feed the inverter, but then you're actually using the battery. But nevertheless, if you need to, you can run it off battery, even if there is an AC supply at the mains. For normal operation, you'd want this in mode 1. So I'm pressing and holding the function button to go to mode 1. All right, so now it is being set to mode 1, which is mains priority, and that means that it will charge the battery as it should do. Right, so it is now set to mode 1. Now it goes back into its normal operating position where the mains will charge the battery, and the mains will also be used for the load unless there is load shedding or there's a power outage. Right, so my load is now on and I'm being fed from the mains. In order to get this to work properly, sometimes you need to power the device down completely. I do find that operation is quite finicky and the instructions in the manual are quite vague. I've also noticed when it's on mode 3, it doesn't always charge the battery. So I keep it on mode 1 for the normal operation. Right, on the front of the unit, we've got a massive button to turn on just these DC outputs. Right, so if I turn it on, right, so here I have a little measure for the USB output, and over here is the DC 12 volt output, which I'll also just measure for you. Right, so I can confirm the measure is 12.8 volts from the DC output. Right, so the DC light is on, it's solidly on, and I've plugged in a DC wire, and if I short it, you can see that the DC yellow light here is blinking rapidly. Quick flashing means that it's been an overload or a short circuit. Right, so there you can see it self-corrects and it will now activate the DC output here again. And here at the USB output, it is measuring 5 volts, and I'll just use it to charge a cell phone to see the peak current. This cell phone can charge at over 2 amps. So I'm just seeing the maximum current that is fed to the cell phone, 1.4 amps at about 4.8 volts. Right, on the back I've got 2 outlets, but notice that the AC input is quite close to this outlet. So if I plug in this wire here, notice that it is obstructed by the AC input, especially if the load plug has a strain relief on. So if I try to get this in here, notice that if you want to use a multi-adapter, you will need to block off the other outlet, because if you use this one, notice that it is then going to block the fan. As you can see, it's going to block the fan. And lastly, if you'd like to have a look inside to see the inverter, you just need to take off these handles, and there are screws on the top part of the panel. Right, so having a look on the inside, we can see that there is a significant toroid transformer here. There's an output board here, probably for the charging of the battery. If for some reason you need to measure the charging voltage across the battery or the output for the charger, it's the red wire and then the second black wire, and there I can get the battery charge voltage. And then on the other side here is the inverter. So we have the fan blowing onto some heat sinks. All right, just having a functional look at the unit. Here is the red wire coming from the battery. There's the black wire, there where my finger is pointing. So there's the positive and negative fed onto the inverter board, which is obviously going through this set of MOSFET, which are probably in an H-bridge configuration or something similar to pulse the DC. This thick red wire and the black one towards the back there are then going into the toroid, but the red wire is first going around this core, and then it goes into the toroid at the back, which then steps it up for the output. Obviously the outputs are just connected in parallel. On the front here is just your switch to turn on your DC section, and there are the boards which one sees on the front. So those boards are for this and these LEDs, and then obviously for the DC output. One thing that I find strange about this unit is that to turn on the DC, I use this significant switch, while to turn on the unit for the 1000 watts, I press this pad type switch over here. Maybe the DC switch should be smaller and the load on off should be this. Anyway, so there are some of my thoughts on this RCT MegaPower and how it functions. Thanks for watching, and cheers.